Okay, so hopefully by now you're used to the idea of Pascal's triangle. So Pascal's triangle was something that you learnt in your investigation task, and it was a triangle that represented the relationship between the coefficients of binomial expressions and the triangle itself. So we're going to quickly use Pascal's triangle to expand these expressions. Now I'm going to start with these harder ones. It's important to remember that we must apply the power of Pascal's triangle and the coefficient to the whole expression. So in this question, when we apply the power of 4, for example, we're not applying x to the power of 4 by itself, we're applying it also to the 2. So we're going to use Pascal's triangle to expand 3 plus 2x to the power of 4. Now, the fourth row of Pascal's triangle, or it's really the fifth because we start at 0, is 1, 1, 4, 6, 4, 1. So applying that knowledge, if we expand this using Pascal's triangle, it's 3 to the power of 4 plus 3 to the power of 3, 2x to the power of 1. So we've decreased the power and then introduced our second term. Plus, and I keep doing this, we need to times our 4 out here from Pascal's triangle, plus 6 times by 3 to the power of 2, 2x to the power of 2, plus 4, 3, 2x to the power of 3, plus 1 times by the last one's quite obvious, 2x all to the power of 4. Now it's important to note that the powers in each term always add up to the value of n. So 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and so on. All we have to do is now figure out these coefficients. So 3 to the power of 4 is 81, plus 4 times 3 cubed times by 2 is 216, x, plus 6 times 3 squared times 2 squared is 216 again. 6 times 3 squared, yep. 216. No, that one's 72, I apologize. That's 72, this is 216, x squared, plus 4 times 3 times 2 to the power of 3 is 96, x cubed, and 2 to the power of 4, I believe 16, so plus 16x to the power of 4. Okay, this one here is quite similar, except we're going to have a negative. Now we should note that our 5, the fifth row of Pascal's triangle, is 5, 1, 10, 10, 5, 1. So it's 1 to the power of 5 plus 5 times by 1 to the power of 4 minus x to the power of 1 plus 10 times by 1 to the power of 3 minus x squared plus 10 1 to the power of 2 minus x to the power of 3 plus 5 1 x to the power of 4 minus x to the power of 4 and finally plus minus x to the power of 5. Now 1 to the power of 5 obviously is 1 plus, it's going to be a minus actually, so 1 minus 5x. Notice that our odd powers will remain negative and the even powers will our negative will go away, plus 10x squared minus 10x cubed plus 5 x to the power of 4, and that's a minus actually, minus x to the power of 4, no it is a plus, sorry, plus x to the power of 4 because it's an even power, minus x to the power of 5 because it's an odd power. Okay, this one here, we're looking at the fifth row of Pascal's triangle. Again, it's 1, 5, 10, 10, 5, 1. Now, this is going to get a lot easier when we actually apply this to the binomial theorem of combinatorics, but for now we're just using Pascal's triangle. So our first term is going to be Not 1 to the power of 5, but 2 to the power of 5, because that's our term here. 2 to the power of 5 plus 5 times by 2 to the power of 4 times by minus x squared to the power of 1 plus 10 times by 2 to the power of 3 minus x squared to the power of 2, noting that our powers are always adding up to 5, plus 10 2 to the power of 2 minus x squared cubed plus 5 2 to the power of 1 minus x squared to the power of 4 plus our last term minus x squared to the power of 5. Okay, 2 to the power of 5 is 32. 5 times 2 to the power of 4 is 80. And we've also got that minus, so minus 80 x squared. 10 times by 2 to the power of 3, I believe, is 80. And our squared cancels out that minus, so it's plus 80. And it's going to be x to the power of 4. 2 squared is 4. Plus 40. Oh, it's going to be minus actually, because I've got an odd power. Minus 40 x to the power of 6. Plus, because we've got an even power, 5 times 2 is 10, so 10x to the power of 8, minus, because we've got an odd power, x to the power of 2 times 5 is 10. Okay. Same idea here, the fraction's not going to upset us. So the fourth row of Pascal's triangle is 1, 4, 6, 4, 1. So we've got 1 to the power of 4 plus 1 to the power of 3, making sure we put our 4 out here, times by 4x on 3 plus 6, 1 squared, 4x on 3 squared plus 4 times by 1, 4x on 3 cubed, and plus our last one, 4x on 3 to the power of 4. Now you can see that putting all of these ones in is pretty annoying and obsolete. As you get better at them, you won't have to put the ones in, but for now it's good practice. So we've got 1 plus, let's just go 4 times 1 times 4 on 3 is 16 on 3, so plus 16x on 3. Plus 6 times by 1 squared times by 4 on 3 squared is 32 on 3 x squared. 4 times 4 on 3, and we're cubing the 4 on 3 this time, and times by 1, we get plus 256 on 27 x cubed, and then 4 on 3 to the power of 4 is 256 on 81, so plus 256 on 81 x to the power of 4. Okay. I'm giving you a nice hint here. Whenever you see binomial expansions and fractions, you need to make those, fractions with pronumerals on the bottom, you need to make those negative exponents. So we're going to rewrite this as 2x minus 3x to the power of minus 2 to the power of 5. We're going to note that the fifth row of Pascal's triangle is 1, 5, 10, 10, 5, 1. And we're simply going to expand. So our first term is going to be 2x to the power of 5 plus 5 times by 2x to the power of 4 minus 3x to the minus 2 plus 10, 2x cubed minus 3x to the minus 2 squared this time plus 10, 2x, should change colors, plus 10, 2x to the power of 2 minus 3x to the minus 2 cubed this time, plus 5, times by 2x, times by minus 3x to the minus 2 to the power of 4, and plus our last term, nice and easy, plus minus 3x to the minus 2 all to the power of 5. Now we're going to pay close attention when we expand these, because we've got in most of them 2 x terms and we need to combine them to be 1. So 2 to the power of 5 we've done before, it's 32, x to the power of 5. We're going to say minus, and we're going to consider our numbers first. 5 times 2 to the power of 4 times by minus 3, or we've considered the minus, so just times 3, is 240. We've got an x to the power of 4 and an x to the power of minus 2. If we add those together, we get x squared, because we're timesing. And we know that when we times indices, we add the powers. Plus, we're doing our numbers first. 10 times 2 to the power of 3 times by 3 squared is 720, so plus 720. Now we've got an x cubed and an x to the power of minus 4, because 2 minus 2 times 2 is minus 4. So 3 minus 4 is x to the minus 1. Let's do our numbers first. 10 times 2 squared times by 3 to the power of 3 is 1080, plus 1080. We've got an x squared and then a minus 6. So we get x to the power of minus 4. And then plus, we've got 5 times 2 times by 3 to the power of 4 is 810. We've got 1x and then an x to the power of minus 8. Combining that, we get x to the minus 7. And plus our last, I think I've forgotten some minuses here actually. So we should have a minus right there. And then a minus here. And then we're plus, no, I've done that wrong. So minus, there should be a plus here, a minus here, a plus here, and then there'll be a minus right at the end. So it usually alternates when you have a negative in your brackets. It alternates. It starts with positive and then alternates. We're going to have 3 to the power of 5 is 243, x to the power of minus 10. Now, if you wanted to be really fancy, you could say this is 32, x to the power of 5 minus 240x squared plus 720 on x minus 1080 on x to the power of 4 plus 810 on x to the power of 7 minus 243 on x to the power of 10. Okay, for the binomial expression, find the coefficient of x to the power of 7. I think in class, I changed these. So I changed this to a 7. I made this a 5 and this a 6, just because I hadn't given you Pascal's triangle for 11. So let's go up. Our Pascal's triangle for 7 is 1, 7, 21, 35. So 1, 7, 21, 35, 35, 21, 7, 1. Now I memorized that so quickly because I realized that Pascal's triangle is symmetrical in the middle. That's one of the properties of Pascal's triangle, is that they're the same once you get to the middle. So x to the power of 5 is going to be actually the 6th term because we start at 0. So 0, 1, 2, 3, 4, 5 is going to be 21. And the one right after that would be 7. So remember there's n plus 1 terms. So the coefficient of x to the power of n is going to be the n plus 1th term. Okay, this question says expand 1 plus x to the power of 4 as far as the term of x squared. So we should know that our 4th row of our Pascal's triangle is 1, 4, 6, 4, 1. So we get, for part A, for question A, part I, we get 1 plus x, 4x, plus 6x squared, and that's all we had to do. Part 2, we need to expand, hence find the coefficient of x squared in the expansion 1 minus 5x, 1 plus x to the power of 4. Well, we can rewrite this as 1 minus 5x times by 1 plus 4x plus 6x squared plus ... I haven't figured out the rest, don't need to. The coefficient of x squared is going to occur twice. It's going to occur when we expand this 1 over to this 6. So our coefficient of x squared is going to be 6 plus, It's also going to occur when this 5x multiplies with this 4, because x times x is x squared, plus minus 5 times by 4, which is 6 minus 20, which is minus 14. All right, so that's what more the HSC is all about. It's about abstract thinking. It's not purely about applying knowledge of Pascal's triangle. Okay. This is where they get fun. So by writing 1 plus x plus 3x squared all to the power of 6 as 1 plus a to the power of 6, where a is 3x x plus 3x squared, expand 1 plus x plus 3x squared to the power of 6 as far as x cubed. So let's have a look at 1 plus a to the power of 6. Okay. So we're going to expand 1 plus a to the power of 6. We know that the sixth row of Pascal's triangle, let's have a look. The sixth row is 1, 6, 15, 20. Is 1, 6, 15, 20, 15, 6, 1. So let's expand 1 plus a to the power of 6. It's going to be 1 plus 6a squared plus 15a cubed plus 20a to the power of 4 plus 15a to the power of 5 plus, what's going on there? So we've got 1 plus 6a squared plus 15a cubed plus 20a to the power of 4. I think I've copied down the 7th row, I think. Let's have a look. 0, 1, 2, 3, 4, 5, 6. 1, 6. Oh, I know what I've done. Ignore me. So 1 is going to be plus 6a, not 6a squared, plus 15a squared, plus 20a cubed, plus 15a to the power of 4, plus 6a to the power of 5, plus a to the power of 6. Now, the question is telling us that a is equal to 3x squared, x plus 3x squared. And we need to find the value of 1.0103. Now, what I've noticed with this is that 1 plus a, well, we can rewrite that as 1 plus 0.0103. And that's the same as 1.0103. So, therefore, that would make a equal to 0.0103. So we can apply that information to the formula. We're going to say 1 plus 0.0103 to the power of 6 is equal to 1 plus 6 times by 0.0103 plus 15 0.0103 squared plus 20 0.0103 cubed plus 15 0.0103 4 plus 6 0.0103 5 plus 0.0103. Why is that going crazy? The power of 6. Okay. Now, if you figured all that out, you would get, let's go 1. If you type all of that in to 4 decimal places, you get 1.063. And that's equal to 1.0103 all to the power of 6. Was it 4 decimal places? 4. Okay. Now, this is actually quite similar to how your calculators actually work. So your calculators will, for example, for cos and sine, use something called a Maclaurin and a Fourier transformation to calculate things like this. It's a bit different to what we've just done, but it's a similar idea. We're going to find some sort of expression and combination of other values that will help us find the original value. Okay. Some further binomial expansions. So the expansion of x plus y to the n. So we've got some expansions. So these are some expansions of x plus y to the 0, 1, 2, 3, and 4. Okay. Some interesting properties of expansions. So the expansion of x plus y to the n has n plus 1 terms, and each term indices of the x and y are whole numbers adding to n. We've talked about that. The coefficients of the expansion x plus y to the n are the same as the coefficients of the expansion 1 plus x to the n. Okay, that's quite obvious as well. Okay, so we're going to use Pascal's triangle. This exercise is very similar to the last exercise. We're going to use Pascal's triangle to expand out the following. So we know that our Pascal's triangle for 4 is 1, 4, 6, 4, 1. So we've got 2 to the power of 4 plus 4 times by 2 cubed minus 3x to the power of 1 plus 6, 2 squared minus 3x squared plus 4, 2 to the power of 1 minus 3x cubed plus minus 3x to the power of 4. Just calculating those coefficients, 2 to the power of 4 I believe is 16 plus 4 times 2 cubed times by 3, and that's actually going to be a minus, so we've got minus 96 x. 6 times 2 squared times by 3 squared is plus 216 x squared. 4 times 2 times 3 cubed is 216 again. 6 times 4 times 2 times 3 cubed, 216 again, okay. 216, and since it's an odd power, it's going to be a minus there. Minus 216 x cubed. Plus 3 to the power of 4 is 81, so plus 81 x to the power of 4. Okay. Next one here, we've got 5x plus 1 on 5a and all to the power of 5. We're going to note that our fifth row of Pascal's triangle, the sixth row, but it's the row that corresponds to an exponent to the power of 5, is 1, 5, 10, 10, 5, 1. So our first term is going to be 5x to the power of 5 plus 5 times by 5x to the power of 4. 1 on 5a plus 10 times by 5x cubed 1 on 5a all squared. Making sure we're putting the 1/5 as squared as well, not just the a, plus 10 times by 5x to the power of 2, 1 on 5a cubed, almost there, plus 5 times by 5x, 1 on 5a to the power of 4, plus 1 on 5a all to the power of 5. Calculating those coefficients, 5 to the power of 5 is 3, 1, 2, 5, x5, plus 5 times 5 to the power of 4 times by 1 on 5 is 625x to the power of 4a, plus 10 times 5 cubed times by 1 on 5, and we're squaring the 1 on 5, is 50x cubed a, plus 10 times 5 squared times 1 on 5, and we're cubing the 1 on 5 this time, we get 2x squared a, then 5 times 5 times 1 on 5 to the power of 4, we actually get plus xa4 on 25, because 5 times 5 times 1 on 5 to the power of 4 is 1 on 25. And then plus, well, we're going to simply have a to the power of 5 on 5 to the power of 5, which is 3125. Awesome. Okay. I feel like we did this one in class, but let's have a go. So we're going to have 1, 4, 6, 4. No, that's not 6, that's 4. Let me quickly go up and see what 6 is. So 6 is 1, 6, 15, 20. Okay. So again, this is going to get much easier when we officially learn about combinatorics coming all into this. So we're going to have, it's not going to be pretty, but we're first of all going to write this as 2x plus x to the power of minus 2, all to the power of 6. So we're going to have 2x to the power of 6 plus 6, 2x to the power of 5 times by x to the power of minus 2. I'd put those brackets in, it makes it a bit clearer. Plus 15 times by 2x to the power of 4, x to the power of minus 2 to the power of 2, plus 20 2x cubed, x to the power of minus 2 also cubed, plus 15 2x squared, x to the power of minus 2 to the power of 4, almost there, plus 6 2x, x to the power of minus 2 to the power of 5, plus x to the power of minus 2 to the power of 6. Wow. Okay, 2 to the power of 6 is 64 x6 plus 6 times 2 to the power of 5 times by 1 is 192. Now we've got 5 minus 2x's, which is x cubed, plus 15 times 2 to the power of 4 is 240. Now we've got x to the power of 4 minus x to the power of 4, so that's a constant term, plus 20 times 2 to the power of 3 is 160. We've got x cubed minus x to the power of 6, which is minus x cubed, plus 15 times by 2 squared is 60. X to the power of 2 minus 8 is x to the power of minus 6, plus 6 times 2 is 12. And then we've got 1 minus 10 is x to the power of minus 9, plus x to the power of minus 12. Now, I don't have enough room, but it would be nice if you made these negatives into fractional form. What is the value of the term independent of x? It is 240. The term in 1 on x cubed, well, that's this term here, so it's 160 on x cubed is that term. Okay, root x plus root I. What else do I have to do? Quite a bit. Okay. Root x plus root y, okay. We're going to write this, and this is going to take us quite a bit. We're going to write this as x to the power of a half plus y to the power of a half to the power of 7. And we're going to look up our 7th term in the binomial, in Pascal's triangle. So 1, 7, 21, 35. One, 7, 21, 35. Okay, so we're going to say this is equal to x to the power of a half to the power of 7 plus 7 x to the power of a half to the power of 6 times by y to the power of a half plus 21 x to the power of a half to the power of 5 y to the power of a half squared plus 35 x to the power of a half to the power of 4 y to the power of a half cubed plus 35 x to the power of a half cubed y to the power of a half to the power of 4 plus 21 x to the power of a half squared y to the power of a half to the power of 5 plus 7 x to the power of a half to the power of 1 y to the power of a half to the power of 6 and then plus y to the power of a half to the power of 7. And we're just going to simplify that. So 7 x to the power of 7 halves plus 7 x to the power of 3 y to the power of a half plus 21 x to the power of 5 on 2 y to the power of 1 plus, and I'm just raising a power to a power, 35x squared y to the power of 3 on 2 plus 35x to the power of 3 on 2 y squared plus 21x y to the 5 on 2 plus 7x to the half y cubed plus y to the power of 7 on 2. Lovely. And if you wanted to be really nice, you could make all those half powers back into square roots. Okay. Oh, I love these ones. Expand without simplifying. This one actually is so easy, this question. So we're going to realize that this is a binomial expansion and its terms are y and x minus y. You can see that this is a 5 and then a 4 and then a 3 and then a 2 and then a 1, and this goes from 1 to 2 to 3 to 4 to 5. So this is simply the expansion of y plus x minus y all to the power of 5, which is the y's die x to the power of 5. And you think to yourself, why didn't they just write x to the power of 5 in the first place? It's a lovely question. Okay, same idea here. This is just the expansion of x plus y plus, it's actually going to be minus x minus y. We know it's minus because our signs are alternating here, and that means it's minusing. And it's to the power of 6. So this is just simply going to be y to the power of 6. Lovely. Okay. This is where they start to get fun. Now, I haven't done these questions yet, so let's hopefully I can get them. How many have I got? A lot. Okay. Expand 2 minus 3x to the power of 7 as far as the term in x squared, and hence find the x squared in the expansion of that. Okay, so let's recall that our 7th term of Pascal's triangle is, I keep forgetting, 1, 7, 21, 35. 1, 7, 21, 35, 35, 21, 7, 1. Okay, so 2 minus 3x to the power of 7 is equal to the power of 7 plus 21, no, 7. That's a 7. Plus 7 times by 2 to the power of 6 minus 3x. And we only have to go up to x squared. Plus 21, 2 to the power of 5 minus 3x squared. Okay, we're done. Now let's clean that up a bit. 2 to the power of 7, what is it, 128? I'm not sure. Yeah, 128. And then we've got 7 times 2 to the power of 6 times by 3 is minus 1344x plus 21 times 2 to the power of 5 times by 3 squared is 9 is 6048x squared. Right, so we can say that 5 plus x, and we're going to say this is times by 128 minus 1344x plus 6048x squared plus dot 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 plus, oh, we haven't done the rest, so we can just say plus dot dot dot. What is that? Go away. Now the term of the coefficient of x squared, well, first of all, it's going to be this 5 times by that is going to be 5 times by 6048, but it's also going to be this x times by that. So it's going to be plus minus 1344 times 1. So 5 times 6048 minus 1344 is 28896. 28,896. Okay. This next question looks very lengthy, but let's have a go. Okay. Show that 1 over root 3 minus 1 to the power of 4 plus 1 over root 3 plus 1 to the power of 4. Oh, that's quite easy to show that. We're just cross-multiplying. There's probably no point even showing that. We're just cross-multiplying that up to there. That's very easy to show. And then it says by putting the left hand over a common denominator, then simplify the expression using Pascal's triangle. Oh, that's not fun. So I think we have to expand each of these individually. So let's go root 3 plus 1 to the power of 4. Well, the fourth row of Pascal's triangle is 1, 4, 6, 4, 1. So this is going to be root 3 to the power of 4 plus 4 root 3 squared times by 1 plus 6 root 3 to the power of 1 times by 1. I can even put those in if you want. Times by 1, that's going to be times by 1 squared. Oh, that's, sorry, silly Billy. 4, 3, 2, and that's a 2, plus 4 times by root 3 to the power of 1, then 1 cubed, 1 cubed, and then plus 1 to the power of 4. So that's equal to root 3 to the power of 4, I believe, is 9. Let me double check. Yep, 9 plus, now root 3, just quickly over here, root 3 squared, or root 3 squared is 3. So root 3 cubed is root 3 squared times by root 3, which is 3 root 3. So root 3 cubed is 3 root 3. So plus 4 times by 3 root 3 plus 6 times, well, we already said root 3 squared was 3. So 6 times 3 is 18. Plus 4 root 3 plus 1. So this is equal to 9 plus 4 times 3 is 12 root 3 plus 18 plus 4 root 3 plus 1. So 9 plus 18 plus 1 is what? 28 plus 16 root 3. Now I am unsure if I'm correct, so I'm going to substitute. So I'm going to type in root 3 plus 1 to the power of 4 into my calculator. I get a decimal. Let's see if it's the same. It is, so I know I'm correct. Now, root 3 minus 1 to the power of 4 is going to be the same thing, but our signs are going to be alternating. So it's 9 minus 12 root 3 plus 18 minus 4 root 3 plus 1. So the signs have alternated. So it's going to be very similar. We're still going to have our 28, but it's going to be minus 16 root 3. I'm again, though, going to check on my calculator to see whether that's right. So root 3 minus 1 to the power of 4 is 0.28. Now 28 minus 16 root 3 is also 0.28. Okay, so I've got two expressions now. So let's apply that to our formula. So this is going to be 28 plus 16 root 3 plus 28 minus 16 root 3 all over 28 plus 16 root 3, 28 minus 16 root 3. Okay, now this is what we call a difference of two squareds on the bottom. You can actually type that into your calculator. So 28 plus 16 root 3, it's actually just going to be 28 squared minus 16 root 3 squared. But if you're uncomfortable with that, you can just minus type that bottom denominator into your calculator and you'll get 16. So on the top, we're going to have, these will cancel. So we're going to have 28 plus 28, which is 56, over 16. 56 divided by 16 is 7 on 2. That was nice. Now, personally, it would make me very comfortable if I typed in my original question and see if it was 7 on 2. And again, you ask yourself, why didn't they just write 7 on 2 in the first place? Certainly is 7 on 2, so we're correct. Okay, last one. Let's see how long this will take. Remember, I haven't seen these questions for like 4 years, so let's see if I can still do them. This video is getting very long. Okay, let's expand that. So first of all, we're going to realize that our 6th row of Pascal's triangle is 1, 6, 15, 20. I should know that by now. 1, 6, 15, 20, 15, 6, 1. That was beautiful. So first of all, we're going to realize that this is equal to x plus x to the power of minus 1 to the power of 6. So that's going to be really nice, and it's going to be x to the power of 6 plus 6x to the power of 5, x to the power of minus 1, plus 15, x to the power of 4, x to the power of minus 1 squared, plus 20, x to the power of 3, x to the power of minus 1 cubed, plus 15, x to the power of 2, x to the power of minus 1 to the power of 4, plus 6, x to the power of minus 1, 5, plus x to the power of minus 1, 6. So that's equal to x to the power of 6 plus 6, 5 minus 1 is 4, x to the power of 4 plus 15. This is going to be 4 minus 2, so x squared plus 20. It's going to be 3 minus 3, just nice and 20, plus 2 minus 4 is, so 15x. We're going 2 plus 1 times minus 4, so 2 minus 4 is x to the power of minus 2, plus 6. 1 minus 5 is x to the power of minus 4. And we've got plus 6, x to the power of minus 6. Lovely. Okay, if u is equal to x plus 1 on x, express x to the power of 6 plus 1 on x to the power of 6 in the form u to the power of 6 plus au to the power of 4 plus u squared plus c. Wow. Okay, Part B is quite interesting. There's quite a number of things that we had to do, and I actually had to sit down and think about it. So, to solve part B, we need to, first of all, realize the things I've done in yellow and blue. So we can see that we've got an x to the power of 6, and we've also got an x to the power of minus 6. So we're going to say x to the power of 6 plus 1 on x to the power of 6. Plus, we've got 6, and we've got x to the power of 4 plus 1 on x to the power of 4, plus 15 x squared plus 1 on x squared plus 20. Okay, so that's just rewriting what we've already got. Now this is good and bad. The good thing is we want this. The question is telling us that we want an expression for x to the power of 6 plus 1 and x to the power of 6. The bad things is all of this. We don't want any of that, and we don't care about it. So we need to try and get rid of it. The problem is we have to let u equal x plus 1 on x, and we don't have that anywhere. It's important to realize that we can't write this as x plus 1 on x all to the power of 6. That's not how that works. So we're going to do a bit of working to try and get rid of all of this stuff. We're going to do that by doing something a bit strange. We're going to first of all consider, well, oh, that's annoying. We're going to first of all consider what is the value of, well, oh my god, that's very annoying. What is the value of x plus 1 on x to the power of 4? Because that is our u. We can make this equal to u. It's going to be u to the power of 4. And we're going to use that, and we're going to be able to get rid of this. So this is going to equal, it should be equal, I'm just going to quickly do this quickly. It's going to be x to the power of 4 plus 4x squared plus 6 and plus 4x to the power of minus 2 plus x to the power of minus 4, which is going to equal x to the power of 4 plus 1 on x to the power of 4 plus 4 x to the power of 2 plus 1 on x squared plus 6. And that's going to equal u to the power of 4, because we have told us in the question we're going to let u equal x plus 1 on x. Okay, we're going to do the same thing. We're almost there. We're going to do the same thing for x plus 1 on x squared. Well, that's going to be much easier. That's going to be x squared plus 2 plus x to the power of minus 2, which is equal to x squared plus 1 on x squared plus 2. But, whoa, we're almost done because this is u squared. So, we've got a few beautiful expressions here. I'm going to call this equation 1 and this equation 2. I'm going to go over to here, just go on to the next page. So from equation 2, x squared plus 1 on x squared is equal to u squared minus 2. Okay, we're going to call this equation 3. And we're going to substitute 3 into equation 1. So we've got u to the power of 4 is equal to x to the power of 4 plus 1 on x to the power of 4 plus 4 times by, we've just discovered that this is this. So 4 times by u squared minus 2 plus 6, which is u to the power of 4 is equal to x to the power of 4 plus 1 on x to the power of 4 plus 4u squared minus 8 plus 6. Rearranging that, we're going to say x to the power of 4, which is what we didn't want in the original expression, is equal to u to the power of 4 minus 4u squared minus 8 plus 6 is minus 2. So we're going to have down here a plus 2. Okay. So, therefore we know that 1 on x squared plus x squared is equal to u squared, what did we say, minus 2? And x to the power of 4 plus 1 on x to the power of 4 was equal to u squared minus 4u squared plus 2. Okay. Now, we have already stated before that x plus 1 on x to the power of 6 was equal to x6 plus 1 on x to the power of 6 plus, what was it, 6, x4 plus 1 on x4 plus 15 x squared plus 1 on x squared plus 20. Now this is equal to u to the power of 6 equals, we don't have anything for this, x to the power of 6 plus 1 on x to the power of 6 plus 6. We've already determined that this was equal to u squared minus 4u plus 2. And we've decided that this was 15 times by u squared minus 2 plus 20. So the u to the power of 6 is equal to x to the power of 6 plus 1 on x to the power of 6 minus 6u squared minus 24u plus 12 plus 15u squared minus 30 plus 20. So u to the power of 6 is equal to x to the power of 6 plus 1 on x to the power of 6. There is minus something's gone wrong. Uh-oh. Oh, sorry. This is u to the power of 4. That's my fault. Or that doesn't change much. All it means is, so I made a mistake. That's u to the power of 4 up there, which would make that a u to the power of 4 and that a u squared, which would make that a 4 and that is squared. So we've got let's see, we've got minus, and that's going to be a plus there. So we've got a plus 6u to the power of 4. I've used that. I've got, how many u squareds do I have? Minus 24 plus 15 is minus 9u squared. And then I've got 12 minus 30 plus 20 is 2. So, therefore, x to the power of 6 plus 1 on x to the power of 6 is equal to, subtracting all of this to the other side, is equal to u to the power of 6 minus 6u to the power of 4 plus 9u squared plus 2. Oh my god. Okay, and that's in the form we were after. So that is in the form a 6u to the power of 6 plus au to the power of 4 plus bu squared plus c. So therefore, a equals minus 6, b equals 9, and, ooh, silly me, that's a minus, so c equals minus 2. That was very, very hard, but I really enjoyed it. Hope that makes sense.